Hello. In this video I would like to talk about two things. The first is how to remove files from an existing Git repository. While this sounds like a simple thing to do, and it is, there is a subtlety that you need to see to appreciate. The second thing I will discuss is how to create branches from the existing master branch. This is a useful technique if you wanted to experiment with your software repository without interfering with its contents. Okay, in the first case, I will clone an existing remote repository. If you're connected to the internet, and I'm guessing you are since you're watching this video, you can type the command that I have here to clone this repository. It creates a folder called cool underbar software. And if we look inside, there are 4 files. They've already been added. Now let's look at the commit history or the commit log to get an idea about what's been happening here. And you'll see that there were a number of commits applied to this repository. Now the commit messages are minimal. In reality, they should probably be more meaningful, but these are all just examples. If I do a git status, let's just see what's going on. It says the branch master is up to date. So let's say that for whatever reason I wanted to remove this file, script2. Maybe I'm tired of experimenting with it. I feel that it doesn't have a place in the repository. So if I type rm, which is the operating system command in Unix to get rid of a file, and then I type ls, the file is gone. How does Git interpret this action? Well, we type git status and we'll see that Git has definitely noticed that we've removed it. And it tells us a couple of things, but these two messages are the most relevant right now. It says use git add/rm file to update what will be committed. What it's telling us is that maybe we should have typed git rm script2 to inform Git that we really want to remove this from the repository. So if a user clones this repository, they won't see that file. Okay, all I've done is simply removed it from the operating system level, which means it would still show up in the repository. This is the subtlety I was talking about. In the second case, Git is basically acknowledging the possibility that we may have removed this file prematurely, or it knows we might be a newcomer here. So it says, look, if you wanted to discard the changes, that is, if we wanted to undelete this file, here's all we have to do. We can do this checkout command. So let's do that. The file magically reappears. Okay. So if I wanted to truly delete it from the repository, I would type git space rm script2. We see that the file is gone. We see that Git removed it for us, and if we issue the status command, we see that it's deleted, although we have to make a commitment here. So I will commit this change, deleted script2, and we get back validation of the commit. And if we look at the status, it looks clean. If we look at the log history, we see that in fact we have deleted that script. Now if someone clones our repository at this point, they won't see the file script2. Had we just deleted it with the operating system, if they had cloned it, they would have seen it. Okay, that's the subtlety I was making reference to earlier. So it's something that you have to keep in mind when you want to remove a file. In this segment, I would like to discuss branching, which is a very powerful technique that allows us to further develop our code and address bugs or add new functionality in a way that doesn't impact the existing repository. So it's frequently the case that a downstream user of our repository could identify some problem. We definitely need to fix it, but until we've addressed the fix in a way that satisfies us, we don't want our experimentation to interfere with someone's productivity. All right, I'm going to create a new repository here. And I've created a folder called temp. And I will add a couple of files. Okay, we have 3 files here. I will add them for tracking, and then I will make a commit. One thing that I've avoided talking about in the earlier videos is this output when we do a commit. It says master root commit. Okay, so what does this master business mean? And you've probably already seen it too when I do a git status. It says on branch master. Okay, so Git uses this concept of branches, and the master branch, or branch master, is the canonical primary reference for our repository. And so if we make this available to users either on Bitbucket or GitHub or even on this local hard drive, they get a primary reference, and they can use this code. Git has provided us a mechanism called branching that allows us to make copies of this master branch and experiment without impacting the code in the master branch. So how would we create an alternative or experimental branch? It turns out it's very easy. I want to check out the contents of the master branch into a new branch called experiment, and this single command line will accomplish that. So I get a message that says switch to a new branch experiment. It's always helpful to use git branch to tell me what branch I'm on. So in this case there are 2. Experiment is highlighted in green and the asterisk is next to it. That tells me that I'm in the experiment branch. Now to switch back and forth between branches, I can use this command. Git checkout master will put me back on the master branch. If I type git checkout experiment, I'm back in the experiment branch, and so on. Okay, so to convince you that these are 2 distinct branches, that is, the activity in one will not impact the activity in other, let me make some modification. I'll just remove script 1 altogether from the repository, and I will create a script 3. Okay, library. And I will add all of these files for tracking, and then I will make a commitment. One and added script 3. I want you to see that when I did the commit, it references the experiment branch. It's tracking these changes only in that particular branch. We have a delete and a creation. If I go back to the master branch, you see that those files are still there. Script 1 rather is there, script 3 is not. So I'm maintaining a separate development branch and experiment. Now let's say that that's all the work I needed to do. In the experiment branch I satisfactorily addressed all the problems, and now I want to merge those changes from the experiment branch back into the master branch. That is easily done using the merge command. Git space merge experiment. Okay, I get a couple of messages here. It's updating a commit. We removed script 1 and we added script 3. And if I do the git status, everything is fine. Now this fast forward business basically means that we made changes independently of the master branch. We actually made commits. So the master branch has to catch up with the changes that we made in the experiment. That's why it says fast forward. After we've made our changes, we can eliminate the branch. And we do that by typing git branch experiment, in this case D. You see that it's gone. We no longer need it. And as far as Git is concerned, that's it. We only have one branch now. In this last segment, I would like to show you how to push the repository that we just created on our hard drive up to GitHub. This is for remote hosting and distribution, and it also serves as a backup. So how would we do this? Well, first we have the repository local here. We know that. I would log into my GitHub account. I've already done that here, and I would create a new repository. And I will name it temp. That's what our existing folder name is. Now, I don't have to keep the same name, but I will just for consistency. And the description is simple. So I create the repository, and it presents a couple of examples here. The second one is the one that we're interested in. This is how we push an existing repository from the command line. The first thing that we do is add a remote destination. It's called adding an origin. So over in my command line, my terminal window, I will type git remote add origin. And so it provides the URL of the repository I just created. And next I'm going to push the repository up. I paste that in. And we get some information. It pushed these objects up to the web. And if we go over to my project, we now see the README file and the two script files are here. So I could publish this URL to users and they could start pulling and cloning this repository. And on my side or on my local hard drive, I could continue to develop changes and new functionality, and when I felt like it, I could push it up. So pretty cool.